What if Earth's oceans weren't born here at all? Imagine that the very water covering our planet, filling rivers, crashing on beaches, even sitting in your glass right now, was delivered by ancient visitors from the far reaches of space. For decades, scientists have argued over this cosmic mystery. Some claimed asteroids brought it, others believed comets were the true carriers. But now, one fiery traveler known as the Devil Comet has revealed something astonishing. A clue so powerful that it might finally rewrite the story of where Earth's oceans truly came from. Billions of years ago, Earth was anything but blue. The young planet was a violent, molten world. Volcanoes erupting non-stop, asteroids slamming into the surface, and temperatures so extreme that any liquid water would have instantly boiled away. Yet today, over 70% of our planet is covered in oceans. So where did all that water come from? For decades, scientists have chased the answer. Some argued that asteroids, packed with hydrated minerals, delivered the water slowly over time through countless impacts. Others pointed to comets, icy wanderers carrying vast reserves of frozen water that could have showered Earth with oceans in massive bursts. The truth remained elusive because each theory came with problems. Asteroids didn't seem to carry enough water, and most comets studied so far contained the wrong chemical fingerprint compared to our seas. This debate set the stage for one of the greatest scientific mysteries of all time, the origins of Earth's oceans. And that's exactly why a single strange comet, burning through space with an otherworldly glow, is now turning heads around the world. Its official name is 12P Pons-Brooks, but astronomers quickly gave it a far more dramatic nickname, the Devil Comet. Unlike most comets, which streak across the sky quietly, this one is prone to sudden and violent outbursts. Massive eruptions of gas and dust shoot out from its surface, creating shapes so strange they resemble glowing horns in the night sky. That haunting image, like a fiery, horned creature, earned it the devilish title. But there's more to it than just appearances. The Devil Comet belongs to a rare family known as Halley-type comets, which take centuries to orbit the sun. This means they've preserved ancient material from the dawn of the solar system, locked in ice for billions of years. To scientists, comets like this are cosmic time capsules, frozen records of what the early solar system was made of. That's why telescopes across the world have been tracking it so carefully. Each outburst, each trail of dust, is a chance to study the chemical secrets it carries. And within those icy remains, scientists recently uncovered something no one expected. To solve the mystery of Earth's water, scientists don't just look at how much ice a comet carries, they study its chemistry in extreme detail. The key lies in something called the DH ratio, or deuterium to hydrogen ratio. Think of it as a cosmic fingerprint. Regular hydrogen has just one proton, while deuterium, its heavier cousin, has both a proton and a neutron. When you compare how much deuterium there is relative to hydrogen in water, you get a unique signature. Earth's oceans have a very specific DH ratio, and if another source of water, say a comet or asteroid, matches it, then there's a good chance they share a common origin. Here's the catch. Most comets studied in the past didn't match Earth's oceans at all. Their DH ratios were either far too high or wildly different, making them poor candidates for seeding our planet with water. For years, this mismatch pushed scientists towards the asteroid theory. But then came the Devil Comet, and it held a surprise that no one saw coming. When astronomers finally analyzed the Devil Comet's icy plume, they found something astonishing. For the first time, a comet's water showed a deuterium to hydrogen ratio nearly identical to Earth's oceans. After decades of searching, the cosmic fingerprint matched. This was more than just another data point. It was the strongest evidence yet that comets could have delivered the very water that fills our seas. For years, every comet studied seemed to tell scientists, no, we're not the source. The Devil Comet, on the other hand, was like a witness stepping forward with undeniable proof. The discovery doesn't just reopen the comet debate, it reshapes it. If one comet carries Earth-like water, how many others might have as well? Could countless impacts billions of years ago have filled the empty basins of a young, scorched Earth with oceans? The answers may still be hidden in the darkness of space, but one thing is clear. The Devil Comet has tilted the scales in a way no one expected. Not everyone is convinced that comets are the answer. For decades, many researchers lean toward asteroids as the more likely water carriers. Unlike comets, which spend most of their lives far from the sun, asteroids are rocky bodies that often contain hydrated minerals, crystals that lock water inside their structure. When these rocks slammed into early Earth, they could have released that water slowly and steadily, building up our oceans over time. The asteroid theory made sense because until now, most comets didn't fit the chemical profile of Earth's water. Their DH ratios were far off, while asteroid samples from meteorites looked closer to home. For years, that tilted the evidence against comets. But the Devil Comet changed the conversation. With its Earth-like water signature, it showed that comets can't be ruled out so easily. Some scientists now argue the truth lies somewhere in between. Earth's oceans may not have come from a single source at all, but from a cosmic cocktail of both asteroids and comets. And if that's the case, then the story of water on Earth is even more complex and fascinating than anyone imagined. Water alone doesn't make a world alive. For life to begin, it needs more. Organic molecules, the chemical building blocks of biology. And comets don't just carry frozen water, they also contain a rich mix of carbon compounds, alcohols, and even amino acid precursors. In other words, they're not just ice balls in space, they're cosmic delivery trucks of chemistry. We've already seen hints of this before. When the European Space Agency's Rosetta probe studied Comet 67P, it detected organic molecules scattered across its surface and in its tail. If the Devil Comet and others like it carried both water and organics, then their ancient collisions with Earth could have done more than just fill the oceans. They might have scattered the seeds of life itself. This idea, known as panspermia, suggests that the basic ingredients for biology may travel between worlds, hitching a ride on comets and asteroids. It's a concept as unsettling as it is thrilling, because if Earth was seeded this way, then perhaps life could spark wherever water-rich comets fall across the universe. And that raises a far bigger question. How common might life really be? If comets help transform Earth from a barren rock into a water world, then it's only natural to wonder, where else has this happened? Our solar system alone offers intriguing clues. Jupiter's moon, Europa, and Saturn's moon, Enceladus, both hide oceans beneath their icy crusts. Astronomers believe repeated cometary impacts could have helped deliver or replenish that water, creating vast hidden seas that may still harbor microbial life today. And beyond our neighborhood, the possibilities multiply. Around distant stars, telescopes like the James Webb Space Telescope have already detected water vapor in the atmospheres of exoplanets. If comet impacts are a universal process, then many of those worlds could have received the same cosmic gift that Earth did. Instead of being rare, watery planets might be scattered everywhere across the galaxy. That changes the way we think about life. If water, and maybe even life's building blocks, can hitch a ride on comets, then the story of Earth may not be unique. It may be part of a cosmic pattern, repeated countless times on countless worlds. The Devil Comet isn't just about our oceans. It's a reminder that the universe itself may be far more alive than we ever dared to believe. The Devil Comet may have given us a powerful clue, but it's only the beginning. To truly understand where Earth's water came from, scientists need more than one lucky match. They need a larger sample of comets, and that's exactly what the next generation of missions is preparing to do. The European Space Agency's Comet Interceptor, scheduled for launch in the 2030s, will be the first mission designed to chase down a fresh, untouched comet entering the inner solar system for the very first time. Unlike the Devil Comet, which has circled the sun many times, a newcomer would be pristine, its chemistry preserved since the birth of the solar system. Studying one directly could confirm whether Earth-like water is common among these icy travelers or just a rare exception. Meanwhile, ground-based observatories and the James Webb Space Telescope are already pushing comet science further than ever before. By peering into their tails and icy cores, astronomers can now decode their chemical secrets with unprecedented precision. Each discovery brings us closer to solving the riddle of our own oceans, and perhaps even rewriting the story of how habitable worlds form across the universe. The Devil Comet has given us the strongest evidence yet that Earth's oceans may not be Earthborn at all, but gifts delivered from the stars. For now, the debate continues, asteroids, comets, or both. But one thing is certain, our planet's story is deeply connected to the wider universe. Every wave that crashes on a shore, every drop of rain, every sip of water could be a trace of an ancient traveler that once streaked across the skies. And if that's true, then life on Earth isn't just local, it's cosmic. If you enjoyed this video, hit the like button, subscribe, and let us know in the comments what we should cover in the next episode.